Okay, so to start our next unit on rational expressions and functions, we have a warm-up on page 1. We're going to activate some prior knowledge about arithmetic with fractions before we get into rational expressions with variables. To add fractions together, you need a common denominator. Using the least common denominator is the easiest. So I can change 1/2 into 3/6. That's still an equivalent value of 1/2. And I can change 1/3 into 2/6. When you add fractions together, you add or subtract the numerators, but the denominator stays the same. You can think of it as having 3/1/6 plus 2/1/6 for a total of 5 of those items, which is why it's just 5/6. So this is for adding and subtracting. The denominator, or the 1/6, is the items that you're adding together. 5 and 3. Okay, take a minute, think, what would the common denominator equal when the denominators are a fifth and a third? So 4/5 we're going to multiply by 3/3, and 1/3 we will multiply by 5/5. The reason you have to multiply the numerator and denominator is because the fraction you're multiplying by is equivalent to 1. So 1 changes the way this fraction looks, but does not change the value. So 12 minus 5 is 7. So we have 7/15. Okay, pause the video. You try number 3. Right, did you make a common denominator of 10? So we get 35/10 plus 4/10 for 39/10. When multiplying fractions, we do not need common denominators. When we multiply numerators and multiply denominators. Dividing is the same operation as multiplying by the reciprocal. So I flip this fraction. Now I can multiply numerators, multiply denominators. And last but not least, multiply numerators, multiply denominators. But 6 and 40 are both even numbers. This fraction reduces. So it would have been easier to notice a step or two before that I can reduce the 2 and the 8. So now we have a numerator of 3 and a denominator of 20. Okay, so the new part is adding and subtracting with expressions. So we have these steps every time. So I want you to pause the video here and write these steps down either on the cover of your packet, on the top of page 2, or underneath your warm-up where you have space. So pause the video to write the steps down. Oops. Okay, now we're going to follow our steps to simplify number 1. Factor every denominator. So the first part of this fraction does not factor. I will rewrite it. Minus. Okay, leave the numerator the same. It just says factor the denominator. So rewrite my numerator. Okay, for the denominator, I'm thinking what multiplies to -21 that adds to -4. So multiply to 21 would be 7 times 3. And to add to -4, you've got -7 plus 3. Now we're going to create our least common denominator with multiplication. So I notice that both denominators share x minus 7. That's great. They already share that. So my left fraction here is missing the x plus 3. So if I multiply the numerator and denominator by x plus 3, now I've created a situation where I have the least common denominator. Okay, part 3, simplify the numerators. We're going to multiply our binomials together. X times x, x times 2, 3 times x, 3 times 2, now, subtraction is the same thing as plus a negative of the entire numerator. So I'm going to subtract x squared, subtract 4x, subtract 13. This negative has to get distributed to all of those pieces of that trinomial. And since we have a common denominator, I could create this one denominator between the fractions. I've added them together. So now my last step is combine the like terms. So x squared minus x squared is 0. 2x plus 3x minus 4x creates 1x. Positive 6 minus 13 is minus 7. This one is optional, so I can keep it. So I've got a numerator of x minus 7 and a denominator of x plus 3, x minus 7. The last step, simplify more if you can. I can. X minus 7 divided by itself simplifies to 1. Any term divided by itself is 1. So our final answer is 1 divided by x plus 3. Okay, let's try that again on number 2. Factor every denominator. So what multiplies to 2 that adds to 3 would be 1 and 2. X squared minus 4, that's the difference of perfect squares. So we're going to factor that to x plus 2, x minus 2. All right, now the common denominator. I notice that both denominators share x plus 2. That's great. I don't have to change that. But the left fraction has an x plus 1 that the right fraction does not. So I need to include an x plus 1 on the right fraction. And the right fraction has an x minus 2 that the left one does not. So I need to multiply the numerator and denominator by x minus 2. All right, so our common denominator is x minus 2 times x plus 1 times x plus 2. The order of your multiplication does not matter. So if you have your binomials in a different order, totally fine. Okay, so now we have to simplify the numerators. X times x, x times negative 2, negative 4 times x, negative 4 times negative 2. Keep going. Now we have plus x times x, x times 1, 3 times x, 3 times 1. All right, now we have to combine our like terms. I see x squared plus x squared. That's 2x squared. I see plain x's here. So negative 2x minus 4x is negative 6. Negative 6 plus 1 more is negative 5. Plus 3 more is negative 2x. And then the constants, 8 and 3, add to 11. This numerator is not factorable. It does not rewrite as a multiplication problem. So we are finished, number 2. Okay, page 3. Let's try it again. Pause the video here and factor the denominators in number 3. So the second denominator does not factor, but the first denominator is the difference of perfect squares. So we're going to factor that to conjugates, which is x plus 3, x minus 3. Okay, pause the video again. Try to create your common denominator. I notice they already share the x plus 3, so this right fraction is missing the x minus 3. So nothing to simplify on the first part. Adding, that's nice. So now we multiply. We keep our common denominator. All right, one more step, combine your like terms. I prefer to write my numerators in standard form so that x squared comes first. Then we have x minus 3x plus 12x. So let's see, x minus 3x is negative 2, plus 12 is positive 10x. And then our constants, negative 5 and negative 36 is negative 41. So let's check. Can we simplify any more? Does the numerator factor? What multiplies to negative 41 that adds to 10? Nothing. So nothing else factors, nothing else will simplify. We are finished, number 3. Okay, one more to go. Let's see how 4 goes. Try 4, factor every denominator. So what multiplies to 6 that adds to 5 is going to be x plus 2, x plus 3. That does not need to be so far. With subtraction, because we will have to distribute the negative, I like to change it to adding a negative. So I would rather write this problem this way, where it's adding the negative of the numerator. Because now when I create my common denominator, when we simplify here and distribute, the negative is going to go to all the parts that it has to. That subtraction has to go to everything after on this right-hand fraction. So by making it adding a negative, I get minus 3x minus 6. Okay, combining our like terms. And that's that. We cannot simplify this fraction anymore. That problem is completely simplified. Okay, your practice is page 4. Check your answers with the answers in Drive and check your work, like annotate it with a colored pen so you know where you made your mistakes and where you have questions, write questions in the margin so that we can go over this on the next class and practice adding and subtracting another day.